Hey guys!
Welcome to our next lesson. We're going to take a look at Lesson 6-2, which is all about similar polygons. So similar polygons are a little bit different than congruent figures, which is what we took a look at before. When we looked at congruent triangles, we used side, 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 angle, side, angle, and things like that. Today, our figures are not going to be congruent, but they are going to be what we call similar. So let's get into this. I would like for you guys to do a split screen with Notability and fill out your notes as I'm going through this video. Polygons with the same shape but different size are similar. And they are similar if they meet two requirements. So the first requirement is that the corresponding angles have to be congruent. So all the angles are going to match up and be equal. However, the sides that correspond to one another, so my corresponding sides, they are going to be proportional. That's just what you did in Lesson 6-1. We took a look at ratios and proportions, so that's why we had to do all of that, because today all of my sides are going to be in the same proportion. And that ratio, again, ratio is what you did in Lesson 6-1, of the corresponding sides is called our scale factor. You may remember learning about that in pre-algebra. If polygons are similar, then their perimeters... Oh, goodness, let me back that up. Are also proportional. Perimeters, remember, we add all of the sides up to get our perimeter. So let's go ahead and take a look at finding a scale factor. And I want to point out something that they put here that says order matters. All right, so they said, what is the scale factor of, and this is what I'm really paying attention to, ABC to triangle DEF. So A to B, B to C, C to A, D, E, F. We've got to go in that order. So to find our scale factor, we could just pick any side on triangle AB and compare it to any side on this triangle. But you've got to go in order. So I'm going to pick the first side, meaning side AB, which is going to be 8, and compare that to a side on the other triangle. So the side on the other triangle that matches up to it is DE. So we'll say 8/12. And from here, all I'm going to do is simplify. So I can divide top and bottom by 4, so I'll get 2/3. That is going to be my scale factor. Okay, now if we take a look, it says what is the scale factor of triangle DEF to triangle ABC. So this is kind of going back to this order matters, right? Now they want triangle DEF. So let's pick another side on triangle DEF. Maybe I'll pick, I'm going to pick the same side. So if I pick side D to E, that's 12. And then if I pick side A to B, the first two letters, that's 8. As I simplify this, I'll still divide by 4. I get 3/2. Please take note that these two scale factors are not the same. And the reason is they first wanted me to do triangle ABC compared to DEF. Then they switched the order on me. And so you really need to pay attention to what you have going on. Finally, they say, what is the ratio of the perimeter of DEF to ABC? So since they picked the DEF triangle first, it's going to be the same as this guy, because this was DEF to ABC. This is DEF to ABC. It's going to be the same exact scale factor of 3/2. Okay? All right, moving on, we're going to take a look at similarity statements. So it says a valid similarity statement must match corresponding angles and sides. Now we saw similarity statements with congruent triangles. So now we're going to do similarity statements with similar figures, and we still have to match everything up. So if I was going to do a similarity statement for the triangles above, I might say triangle ABC is similar. And by the way, for similar, I'm going to come over here. The symbol for a similar figure is just that wave, like the top of a congruent sign. So we're going to say similar to triangle, and it's going to be similar to triangle DEF. One way you can think about this, guys, is if you look at the figure, between A to B, we've got one arc to two arcs, one arc to two arcs. They have to match up. If I look at the next two letters, BC, B to C, it's two arcs to three arcs. That matches with E to F, two arcs to three Fs. And then that leaves that third side, C to A, F to D. So they have to match up. Let's take a look at this question that says, list all congruent angles and write a proportion that relates the corresponding sides. So first, let's just list our corresponding angles. I'm going to make use of that similarity statement. So I know that J and P have to match up. So I'll say angle J is congruent to angle P. Remember, when two figures are similar, all the angles are congruent. Angle K is the next letter. That's got to match up with angle M. So angle K is congruent to angle M. And then finally, I'm going to say angle L is congruent to angle N. So all three of my angles corresponding are congruent. Next, we'll list the sides. The sides are going to be in the same ratio. So if I pick the first two letters, so over here I'm choosing KL, that's got to, or sorry, JK, that's got to match up with PM, the first two letters, and we set that equal to the second two letters, K to L, M to N, and finally, we'll take the first and the third, JL, PN. That's going to be my sides that correspond. All right, let's take a look at another figure. This is kind of like a stacked triangle. I'm going to highlight them so we can see them a little bit more clearly. So first I've got triangle XYZ. Oh, goodness. Let me redo that. Here we go. X to Y to Z. This is going to be the big one on the outside. And then we've got triangle RYS. That's going to be the smaller one at the top here. So as far as angles go, remember all my angles are congruent. Just line them up. Angle X has to be congruent to angle R. First letter matches to first letter. Second letter matches to second letter. So angle Y and angle Y. Finally, third letter Z matches with third letter S. So that's great. Now we can do our sides. XY, that's the first two letters in the first triangle, match up with the first two letters in the second triangle. Then we're going to go second and third. So Y to Z is going to match up with Y to S. Finally, first letter, third letter, XZ over RS. I'd like you guys to take a moment and try number 3. So please pause the video, try this problem, and then when you come back, you'll see if you got it right. All right, so let's take a look. In this one, I'm going to go ahead and set up my angles together. I've got angle J is congruent to angle Q. Angle K is congruent to angle R. Angle L is congruent to angle S. And finally, angle M is going to be congruent to angle P. Now, this is a quadrilateral, a figure with 4 sides, so I have to do 4 ratios. So JK is going to match up with QR. KL is going to match up with RS. LM and SP go together. And finally, we'll do first letter and last letter. So JM over QP. So hopefully you guys got that. Hopefully this is not too challenging. I know you guys are super smart and you will get this. Let's take a look at number 4. So now we're going to find a side length. You can see we have some X's in there. We've got scale factors. We're going to use proportions. Again, we're dropping back to what we did in lesson 6.1. And so it says, if the figures below are similar, with a scale factor of 2 to 3. Find the value of x. So guys, what I'm going to do is I'm going to start out with that scale factor. That's going to be my first ratio. And I have to make a proportion. I'm going to set it equal to 42 over x. Now we're going to solve. So we have to cross multiply. This is the work that we did last week. So I'll multiply the diagonal with the variable first. 2 times x is 2x. Then I'm going to multiply 3 times 42, 126. And we can solve this. Divide both sides by 2. I get x equals 63. So a little bit of algebra, a little bit of dropping back to ratio and proportion. And we'll continue to do the same type of problem. So if we look at number 5, if the figures below are similar with a scale factor of 6 to 5, that is what I start out with. Find the value of x. So we're going to take x all over 28. There's my proportion. To solve this, I have to use cross multiplication. I start with that diagonal that has the variable. 5 times x is 5x. I'm going to multiply my other diagonal. 6 times 28 gets me 168. And now I solve it. Divide both sides by 5, and I get x equals, we get a fraction here, guys. We're going to get 33.6. All right, when we take a look at numbers 6 and 7, they're slightly different because if you notice here, they are not giving me the scale factor. I don't have that. And so I need to kind of set up my proportion just based on what I'm giving. They are giving me the similarity ratio. I have to use that to make sure that my order is correct. So the first 2 letters here, A, B, have to match up with the first 2 letters here, D to E. I'm going to use that to set up my proportion. So I can see that this A to B is X, D to E is 25. That's where I'm starting, X over 25. And I'm going to set that up to the other side that I have. I know side BC is 28, and that's got to match up with side EF, which is 20. That's my proportion. Now we begin that journey of cross multiplying. So I'm going to always do that diagonal with a variable. So 20x equals, and then I'm going to set it equal to my other diagonal. 25 times 28, that gives me 700. Let's solve it. Divide both sides by 20, and we get x equals 35. All right. Let's take a look at 7. So same thing. They're giving me the similarity statement. This is huge because I know what corresponds with what. So I have side PS over here. I might just jump in there. And then we also have side SR. So maybe I'll start with side RS or SR because that's X. So that's the last 2 letters. That has to match up with the last 2 letters on the other quadrilateral, which is going to be Y to Z. So I'm going to begin my proportion with X over 32. And then if I go back to that PS, that's the first and the last letter. So P, oh, sorry. Let's see. I thought that was on the highlighter, but I'm not. So PS is going to be first and last. That matches up with W to Z. W to Z is 40. So we're going to have 75 over 40. That'll be the other sides that match up here and here. Now we use cross multiplication. So x times 40 is 40x. We'll multiply the other diagonal, 32 times 75. Again, this is a review. We did this in the last lesson. That's 2,400. Solving for x means dividing by 40. So I get x equals 60. And I get, oh, goodness, I get x equals, All right, taking a look at the last few questions, it's more of the same stuff, but now they're kind of upping the challenge for us because now we have to find the values of x and y. So we have to be really cautious as we're kind of comparing these sides. I'm going to color code kind of what goes with what. So D to E has to match with H to J. We've seen these similarity statements. D, E, H to J. So right away, I'm going to start with 9 over 15. I know that's got to be a ratio. If I look at my second two letters, that's going to be EF. Sorry, thought I was on that highlighter again. EF and JG. So E to F, J to G. All right, that's perfect because that'll be 14 over Y. Let's go ahead and solve that for Y. Cross multiplication, we've seen this many times. 9 times y is 9y. And then I'm going to go ahead and do my 15 times 14, which gives me 210. Oops. Sorry, guys, this is a little bit different than Notability. Divide by 9, we get y equals 23.3. And you can write that in on the figure if you'd like. Okay, that's wonderful, but now I got to get x. So I'm going to go back to my ratio where I started, that 9 over 15. And now I'm going to go ahead and take a look at the side with x. Guys, that's going to represent the first letter and the last letter. So D to F has to match up with H to G, 12 over x. That's going to be my other proportion. We have to set up two separate proportions because we're solving for two variables. Cross multiplication. 9 times x is 9x. Other diagonal. 15 times 12 is 180. We solve. Divide by 9. I get x is 20. Taking a look at number 9, very similar. I want you guys to try that one. You can take this moment to pause that video, and when you come back, check to see if you got that correct. Okay, so coming back, let's see if you got this right. I got y is equal to 18 and x is equal to 35. The ratio that I started with was this 40 over 16 both times. That was my JK and NM. J to K was 40, N to M is 16. I used that for both of them because I knew both of those side lengths. From there, I used the second two letters. So I used K to L, which was X, and I matched that up with M to L, which was 14. That's over here. Then I found the third side, which was my J to L, 45, and I matched that up with N to L, Y. That's right here. And I solved both proportions by cross multiplication. Last couple of problems are going to give our brain a stretch because we have some algebraic expressions. You can kind of see here x plus 6, x plus 3, so on and so forth for the other problems. But we're going to really do it in the same exact manner, and we've solved proportions like this too. So A to G is matching up with K to X. So A to G, K to X. That's where I'm starting. 32 over x plus 3. Let's set that equal to the next sides that we have. We do have G to M. That's 36. That's got to go over x to D. X to D is x plus 6. As we go to solve this with a proportion, little bit of review, 32 times x plus 6. You have to use those parentheses. Set it equal to the other diagonal. 36 times x plus 3. Let's distribute. 32x. 32 times 6 is going to give me 192. 36x. 36 times 3 is going to give me 108. And then we solve. Oh, sorry, I forgot the x there. So I'm going to do minus 32x on both sides. I get 192 equals 4x plus 108. Move that 108 over. So we get 84 equals 4x. Divide both sides by 4, and we get 21. I'd like you guys to take a moment and try number 11, just like number 10. So at this time, pause that video. When you come back, you can check to see if you got it right. Okay, guys, so I set up my proportion of 25 over 10 equals 4x minus 1 all over x plus 5. We did our cross multiplication, and I worked off over to the side, and I got x is equal to 9, which is great. That, however, is not the answer to this question because they want you to find Ly. So make sure we're reading those directions. We've got one final step. We're going to plug it into the expression for Ly, which is 4x minus 1. I got x is 9, so 36 minus 1 is 35. So again, here are the steps. Please pause if needed so that you can write this down if you did not get that correct. All right, moving on to our final problem, number 12. It says that triangle BNV is similar to triangle BRG. I've got B to R, so I'm going to write this on my figure, is 4x plus 7. Now, guys, B to R is this whole side, 4x plus 7, and B to G is 18. That's this whole side, okay? We have to find the value of x. All right, so let's start by making a ratio. I can see that, let's see, if I'm going by the sides, where am I going to start? B to N, do I know B to N? I do. B to N is 12. That's going to match up to B to R. And guess what? We know B to R, the whole thing, is 4x plus 7. So let's set that equal to our next piece. Now, the next piece would kind of be N to V, and I do know N to V is 10, but N to V matches up to R to G, and I don't know that. So I don't want to use that because I don't know both of those corresponding sides. So that means I'm going to shift my focus to the first and the third, B to V. B to V is 8, and then if I go first and third here, that's B to G, and I know that's that 18. So I'm going to make it 8 over 18. So we kind of have to be cautious of like what we're choosing here. So now I've got my proportion. We'll begin this journey of cross multiplying. I always start with the side that has the variable. So 8 times 4x plus 7. Notice I'm using parentheses there, class. I'm going to set that equal to the product of the other diagonal, which is 12 times 18. That comes out to be 216. We solve. Distribute here. 32x plus 56 equals 216. We move that 56 over. So I get 32x equals 160. I divide by 32. X equals 5. Okay. All right, guys, that is a wrap. Please try the practice. Please fill out the notes. I will see you guys tomorrow, and I hope you have a great day. Bye-bye.